All right. How do we balance redox reactions? We have already established the different definitions of redox, right? We said redox stands for reduction and oxidation, right? Now there are two tricks I first want to show you, especially when you're asked in JAM, that the reaction below, you'll be given a chemical reaction, and you'll be asked, is this reaction a reduction reaction or an oxidation reaction? Usually they give you a half reaction. Now, if you see the electron on the right side, it is oxidation, right? And if you see electron on the left side, it is what? Reduction. Do you understand? So then another trick is this. We've probably done this before, that loss of electron is what? We gave this definition briefly. Loss of electron is oxidation, and gain of electron is what? Reduction. Think of it as Leo the lion goes grrr, like it's roaring. Do you understand? So that grrr is the GER there, and that GER stands for gain of electron, known as reduction. Does that make sense? All right. Now, what are the steps to balance it right? What are the steps to balancing? There are two conditions we'll be asked to balance. We'll be asked to balance in acidic medium, and we'll be asked to balance in basic medium. We'll be asked to balance in acidic medium, and we'll be asked to balance in basic medium. The steps to balancing acidic and basic medium are pretty much alike, especially in the beginning. Do you understand? It follows the same step. Is that okay? Balance atomically. Balance atomically. That is all atoms except hydrogen and oxygen. All atoms except hydrogen and oxygen. Then number two, balance oxygen. Balance oxygen by adding water. By adding equal amount of water to the side with no oxygen. How you know it? Balance oxygen with equal amount of, by adding water. How did I put that? Yes, by adding equal amount of water to the side with no oxygen or less oxygen. To the side with no oxygen at all or less oxygen. Then on the other side, add protons. That's H plus. Add what? Protons. To balance the number of hydrogen. And on the other side, add protons. So, and balance positive charges. That's the next point now. That's balance ionically, or you say balance electrons, balance positive charges by adding. Oh, we missed a step. We said balance. How do we, in the beginning, we said what? Balance atomically. Right, before that, this is what we're supposed to do. Identify the reduction and oxidation half reactions. Or you say split the reactions into half reactions according to oxidation and reductions. Does that make sense? Identify oxidation and reduction half reaction and then split the reaction. Is that okay? So it's on splitting that you now begin to balance atomically. Do you understand? So you have two half reactions. Do you get it? After splitting the reaction, I'm going to have two half reactions. This is the full reaction we're giving. I'm going to split it, and then we'll have two half reactions. So one will be oxidation half reaction, the other will be reduction half reaction. Now, and that's why I started with this. So you will know that with reduction, where are you going to add the electrons? On the left side. Do you understand? On the left side is where you add electrons for reduction. If eventually you are solving and then it happens that you had to add the electrons on the right side for reduction of reaction, then there is a mistake. Do you understand? That's the use of the trick. There's a mistake so that you know where to add electrons. So now we have said at the end we said we should add what? Electrons to balance what the positive charges. Is that okay? Then multiply the by adding electrons. Balance positive charges by adding electrons. Then the next one is to multiply both reactions by a factor, multiply both half reactions by a factor that equates the number of electrons on both sides. Multiply both half reactions by a factor that equates the number of electrons on both sides. Is that one clear? Then cancel out same species that occur on both sides. Cancel out same species that occur on both sides. Then the next one is so that is now balancing acidic medium. Now in basic medium, that's in acid now, right? In basic medium on the line. In basic medium, add OH, equal amount of OH to both sides. Add equal amount of OH to both sides. Add equal amount of OH. OH minus, that is that okay? Add equal amount of OH minus to both sides of the equation. Add equal amount of OH minus to both sides of the equation. To neutralize the acidity, to neutralize the hydrogen ions. Do you understand? To turn it to water, to form water. To neutralize the hydrogen ion and form water. So you notice that. So you know that by the time you finish the equation, there will be a side that will still have H plus, right? So you now add equal amount of OH minus that you need to that side. So by the time you have add OH minus, that becomes what? Water, right? So with that, you have neutralized the acidity. Is that okay? And you will now notice that OH will still be left on one side. So which means that the reaction is now basic. Does that make sense? Is it clear? We said add equal amount of OH to both sides of the equation to neutralize the hydrogen ion and form water. All right. So that's all. That's all. Let's see how to balance this guy. How to balance this guy. So seeing that, how do you split it first into half reactions? So the first is this. Now you notice the species that look alike are this guy and this guy, right? And this guy went from here to here, right? Good. Do you understand? Like I mean, some people might think, why did I not take from this guy to this guy to this guy? Because the major species here is Cr, right? Chromium, and chromium is also here, right? So I relate them. Is that okay? So from here to here, I want to know what happened. Is this oxidation, half reaction? Then the opposite will be this case, right? And it's easier to do for these ones, right? You already know how to do it using oxidation number technique, right? The total oxidation number here is what? Minus 2. Does that make sense? So what we now do because of this minus 2? Total oxidation number here is 0. Once there is no charge on it, oxidation number is 0. Total oxidation here is also what? 0. No charge on it. Total oxidation number here is what? Plus 3. Good. So here, once you know the oxidation number of chromium and the oxidation number. What's the oxidation number of chromium here? Plus 3, right? So it went from what to plus 3? If it went from a higher number to plus 3, that's what? Then it went from a lower number to all the plus 3 is what? Good. We said oxidation is an increase in atomic number. So here, we are looking for chromium, but 2 is given, so it will be 2x, right? Plus 7 into bracket minus 2. Everything should amount to this total charge that is carrying it. So we have 2x equal to 2x minus 14 is equal to minus 2, right? So 2x equal to minus 2 plus 14. 2x equals 12. Divide that by 2, and you have 6, right? X equals 6. So since it's 6 here, it's reduced, right? So that's what? Reduction. So it means that if this is reduction of reaction, this is what? Oxidation of reaction. Now, if I've just said it without doing this for you, some of you might be confused. But other definitions that we give is actually proven by this. So, for example, we said oxidation is the addition of oxygen, and reduction is the removal of oxygen. From here to here, what happened? Removal of. Then we also said that oxidation is the removal of hydrogen. Oxidation is what? Removal of hydrogen. Do you see that now? All right, so it proves it, right? So we now have two half reactions, so we can separate it. We now have oxidation of reaction. It will go from H2O2 to O2. Does this make sense? Then we have Cr2O7 2 minus to what? Cr3 plus. So this is oxidation half reaction, and this is what? Reduction half reaction. You don't have to write it that way, but I've given you the trick already to note. In JAM, what they will ask is mostly, nobody will ask you to balance really in JAM. What you'll be asked to do is, sometimes they could ask you to find the species. They'll put X, Y somewhere, the way they did in balancing chemical here. Sometimes they do that, but most of the time what they will ask is, which one is oxidation? Do you understand? Which one did oxidation take place, which one did reduction take place? Is that okay? All right. So now, if you're writing at this time, now, you are wrong. Focus on the board, now. So from here to here, we said it's oxidation. How do we balance? The same process. We are split into a reaction. We balance atomically. Let's balance atomically. How many atoms of hydrogen have we here? Of oxygen have we here? 2. How many do we have here? You know, in that question, we said, in the rule, we said, leave out oxygen and hydrogen, right? Because there's a special way of balancing them. We have no choice here than to just actually consider them first. They are the only species here. So oxygen here is 2, oxygen here is 2. No hydrogen here, but there's hydrogen here, right? So come and add the amount of how many hydrogen do we have here? 2. So come and add 2 protons here. We come and add what? Even though in the reaction there, I didn't tell you that you should use this to balance hydrogen. But of course, there are only 2 species you can add to your reaction. 4 species. Water, are you with me? Water, H plus, OH minus, and electrons. Those are the only species you can introduce into your reaction from anywhere. Is that okay? Hydrogen, H plus, hydroxide, electrons, and what? Water. All right. So that's why for oxygen, is water we use to balance it. Does that make sense? So here we have added 2 hydrogens and we have 2 oxygens. So this is atomically balanced. Let's try balance that atomically. So Cr is 2 here. How many Crs do we have here? 1, right? Is the charge that is 3? Oh, note that. It's the charge that is 3, not the atoms. So we have 1 atom of chromium here. So we have 2 here. So to make it balance, to become 2, right? Now, there is oxygen here, but there's no oxygen here, right? So balance it last. How do you now balance oxygen? We come and add equal amount of water. How many water do we have? How many oxygen do we have here? We add how many water? 7 water. We've done this in the beginning, right? So you see how it's blazing, right? Now. So we have added a new species here, which is what? Hydrogen, right? This new species, what do we use to balance on the other side? Protons, right? How many protons do we add on this other side? 14. God bless you. So this is now both balanced, both sides are now balanced atomically. Now let's balance ionically. We use electrons to balance the ions. How many ions do we have here? We have 0, right? Now here, what's total ion here? Total charge here, 2 plus 2. Now, when you add electron, the side you add electron to is always reducing the total charge. You always add electrons to reduce the total charge. Is that okay? You always add electrons to do what? Reduce the total charge. So where do we need reduction? Here, right? So we need to reduce this charge. So what do we need to add to this plus 2 to make it equal 0? Minus 2, right? So that will be plus 2 electrons. Is it clear? So does that prove what I said, that you add electrons to the right side for oxidation? Do you now understand? All right. On this side, where will electrons be added? On this left side. Whichever way, just know first. Is that okay? So that you will know that that makes your work minimal, kind of. Is that okay? So here, what's the total charge here? 0 plus 6, that's 6, right? Plus 6. Then on this side, what's the total charge? Minus 2 plus 14, that's what? 12. So it means it's this side we are reducing, right? So how many do we need to add to it to equal to this side? 6, God bless you. So we say plus 6 electrons. Now we are supposed to give enough space in writing, but in practice, really, there's no space sometimes. Is that okay? So you have to just find a way around it. So usually this one should be in the front again. All right. So having done this, it means that what we have is now H2O2 to give O2 plus 2H2 plus 2E minus. And on this side, we have Cr2O72 minus plus 14H plus 6E minus to give 2Cr3 plus 7H2O. Does this make sense? Now, the next thing you do is this. You now equate the number of electrons, because we don't write chemical reactions with electrons. Is that okay? So how do we annul the electrons? We make them balance on both sides, equal on both sides, so they will cancel out. So we introduce a factor, usually a common factor, or sometimes an LCM, that will equate them. So for example, here, the factor we add, what are we going to use to multiply this reaction, or multiply this reaction to equate them? First, which one needs multiplication to become equal to another? This one, right, needs to multiply with something to become equal here, right? You are targeting the electrons, don't forget. So how many electrons have we here? 6. How many electrons have we here? So what do we need to multiply this to equate it to that side? 3, right? So multiply the overall equation by 3. So this becomes, so we say times 3. So this becomes 3H2O2 to give 3O2 plus 6H plus 6E minus. Then Cr2O72 minus plus, yeah, then on this side, we're not multiplying with anything, right? Because it's already equal. Is that okay? Is that one clear? Are you confused? That's because if we do it that way, okay, listen to what I said. We'll still have to reduce. Do you remember? If we do it that way, that one, maybe the example I used for you was odd numbers. So let's say there were 2 electrons there, then 3 electrons there. So in that one, you use the number of electrons there to multiply here, and the number of electrons here to multiply there. So now give you 6, 6 if there are 2, 3. Now it's 2, 6. 2 is a factor of 6. So just use another number to upgrade to that 6. If we do that same thing, we'll get the answer, but we'll have to reduce again. Should I show you what it means? You understand what it means, right? Do you all understand what it means? If we multiply it here, let me quickly explain. If we multiply here by 6, it becomes 6 this, 6 this, 12 this, and 12 this. This becomes 12, 2. This becomes 6 this, 12 electrons. At the end of the day, you see that you can reduce it by 2 throughout. Do you understand now? So why not use the number that we don't need to work on again? Is that okay? So now this is not changing, right? Plus 6E minus to give 2Cr3 plus 7H2. Now, so we now combine our overall reaction. If you already understand it, you can go from here So cancel here and cancel here if you want to. But if you don't understand it, just combine your reactions. Write the overall reaction. We call it the overall reaction. At least for YX students, you should write overall reaction really. You should have half. You should write half reaction really if you're balancing. So now let's go. The overall reaction is this plus this, right? Isn't it? So we'll come from here. 3H2O2 plus everything here. Cr2072 minus plus 14H plus 6E minus. Assuming we have not cancelled the six electrons. To give O2 and this guy. Where is O2 starting from? Here, right? 3O2 plus 6H plus 6E minus. Does that make sense? Then plus 2Cr3 plus 7H2O. Does this make sense? The rule now says you cancel out species that occur on both sides. H2O2, does it occur on both sides? No. H2O2 peroxide, that one is water. Don't mistake it, please. This one is peroxide, this one is water. So don't confuse it. The next one, the next species, this guy is not appearing on the other side. Then H plus, let's see. H plus is appearing here, right? Which side is larger? Just subtract on both sides. Subtract 6 here to become 0. Subtract 6 here to become what? H plus. Does that make sense? Then you come here. That's the use of writing overall reaction. 6 electrons, 6 electrons. Is that clear? So our answer becomes 3H2O2 plus Cr2072 minus to give, plus 8H plus to give 3O2 plus 2Cr3 plus 7H2O. So here's the drill. Once it is acidic medium, water will be on the right hand side. Hydrogen here will be on the... No. I don't know. You just make sure, see, it will always occur that H plus ion will be there. So this is acidic. Hydrogen ion. Is that okay? To turn this thing to basic medium is very simple. Just neutralize this with 8OH. OH minus. But you're adding it here, you must do it to the other side, right? This is going plus 8OH. Is that okay? Number of OH you add should be equal on both sides. Is that okay? At here, to give us what? 8H2O. Does that make sense? At here, nothing will change, right? So H2O water is now 8 here, and we have 7 here, right? This one will cancel out. So remain 1. 7 will cancel out again because now occurring on both sides too again. Is it clear to all of us? So now cancel out and remain 1 water here. So you see the drill, what I was going to say that time. When you see the water on the right side, this acidic medium. At that point, you will see the H plus on the left hand side, really. Is that okay? Then for basic medium, OH will appear on the right side, water will now appear on this side. Is it clear? Alright, if you're sure it's clear, copy that and solve this one for me.